So good afternoon, everyone, on our fifth session of Meet the Oracle Masters Part 2. So today we have a very honored guest with the name of Phil Wilkins from Capgemini. We had previous sessions last week, and we have one session to go next week. But this session today will go about what makes a good API, and Phil will take you in the world of API development and managing everything. So I give the word to Phil now. So I hope you enjoyed the session, and good luck, Phil.
Yes, thank you. Welcome everybody. Today's session is about what makes a good API. My background, very quickly, is this. So very quickly, I am a technical architect and technology evangelist for Capgemini UK, and part of a team that's picked up a number of awards, for which we're very proud. And we've proven to be, very successful with some of the technologies that we provide. Obviously, we work with Oracle, but we work with a lot of open source. Oracle does that now as well these days. And a lot of the material that I present here, in fact, all of the material I'll be presenting today, you can find on my website. So no need to worry about grabbing screens or scribbling notes. It's all available already on my website, mp3monster.org. Aside from being a father, blogger, author, husband, and so on, I also do a fair bit in the Oracle community around developer meetups, and run a developer meetup in London, which has gone virtual with COVID. And we work with a number of other Oracle meetups to offer sessions on a regular basis around Oracle and sort of the leading technologies that are out there today. Obviously written a fair bit, and I'm currently working on a book around FluentD because it's logging has been a long-term pet subject for me. And also worked with a number of other Oracle aces and ace directors in several other titles. I mentioned Capgemini, that's us. I won't say any more about that. If you want to know more, reach out. I can always tell you more about us. What led to this, the presentation really came about as a result of the work we've done around API adoption, and people sort of asking, is this right? Is that right? What does good look like? What would we recommend as a team? And even at times, what defines an API? Is a database, a shared database, an API, and so on. So I went away and I was like, actually, do you know what? We ought to get a definition. So lowest common denominator is Wikipedia, and whilst people challenge it from time to time over its accuracy, I think when it comes to things like this, it's a reasonable source of definition because it's a fairly sensitive, politically biased subject, so on. So it says it's about communications. We'll completely agree with that. And actually, communication can be in many, many different ways. We tend to think about SOAP and RESTful these days, but you can be defining communication protocols using JMS, using Kafka, gRPC, even header files from C libraries is a form of communication. It's a tool to building software. So, we should be thinking about things like mocking and SDKs to support our API. It's a means to communicate amongst components. Yes, it's a contract that should occur between two or more components. Make things easier to develop? Well, absolutely. The whole point is you pick up an API, you want to know how to use it. So the payload should be explained, described, what happens when you use it incorrectly, what happens when you use it correctly but there's a problem, as well as what happens when you use it and it was working smoothly. Oh, sorry, going the wrong way. There we go. So pulling it all together. So it's all about basically communication over an agreed format between various components. So whilst I'm going to focus on largely REST-based stuff here, what you see in the rest of this presentation will hold true for just about any API-based technology. And I deliberately, in the previous slide, make reference to JMS and Kafka and shared databases and even shared files. The underlying principles and objectives and things that we talk about can influence those technologies and their use as an API medium. But we're going to focus on REST because that's the most common way to offer a fresh API. So we are going to talk about that. REST came about actually as a result of a PhD paper from a guy called Roy Fielding back in 2000, which if you look at the timelines isn't too far off when we were just defining and qualifying SOAP and WSDL and the XML based contracts and extensions to those sort of web service based interfaces, which is pretty interesting given where we are today with SOAP and WSDL and less favored now and REST becoming the way most people are going, at least for public service APIs. So Roy identified a number of key factors in his paper, some of which are well understood and recognized, and there's a few in there that I've seen trip people up, so I thought it's worth just going around and calling them out. So when we think about REST, we think about these 6 or 8 key points. So he talked about the use of uniform interfaces and standardization around the use of HTTP verbs. He identified HateOS, which is the idea of giving URIs to other operations on the payload. He identified things as being self-describing. Well, there's no real surprises there.
I guess something has gone wrong. I did think Phil's connection has lost. I hope he will get back soon. I will try to reach him.
Okay, so I was talking about Roy Fielding and his view on REST. So we touched upon the idea of stateless, and one of his interesting ideas that not many people pick up on is the idea that you could pass code through an API call to pass an appropriate bit of JavaScript back and forth based on need. Interesting idea, raises all sorts of security questions, but it is in there if you look at the paper. He then talked about layered and cacheable. Now, this is where I've seen people get tripped up. People tend to develop their APIs, test them locally, and then forget that actually between real clients and servers in the real world is a raft of infrastructure from routers and switches and proxies, plus physical connections, and they all have characteristics that can impact the connectivity. So what might work nicely is a big payload shift in a local connection will time out on some of this potential intermediate technology. So we need to be mindful of that, and often people forget that you know, that's a real challenge, particularly as you get out into the public net as well. And of course, inside of all of that, not only is there physical infrastructure, there is also the ability for these pieces of technology to cache your payloads that you're passing back and forth. And sometimes that's more than acceptable, because actually you don't want the back end being repeatedly called for data that doesn't change very often. But conversely, if you're dealing with share trading, for example, you really don't want that, because the share prices are shifting millisecond by millisecond. Net result is that you want to use the HTTP ability to define boundaries on what can and can't be cached, which is identified and called out in the paper. Yes, it's both a plus and a potential minus. And then, of course, he talks about self-describing and the data being understandable and so on that you're exchanging. So fairly obvious, most of it. A couple of things that people trip up on sometimes, particularly when they get into the nitty-gritty development. But one of the things that we should also consider when trying to deal with APIs and development is how we go about the design process. How do we know what our API looks like, and is it going to be fit for purpose? You can describe several different approaches to APIs, where I will design something, I will then go and build it, unless I'm going a code first model, in which case I'm going to generate my API specification off my code. And actually Swagger version 1 was orientated this way, rather than the way we tend to think about it, of doing the Swagger definition first. Then we obviously, once we got it built, package it and deploy it, try it out, test it, and then only then do we start to get feedback on the design, which is okay in constrained circumstances, but you know, that feedback loop takes a long time before we get any, you know, is the design delivering what is needed style feedback. We could, of course, go into a more agile development model, where we do the design and we're feeding back and we're trying, and we're also passing back the analysis from actual runs, because we're into, if we're doing agile, we're probably doing DevOps and getting the analytics and all those sorts of nice things that will help us get indications of whether the API is doing what people would like of it. But even that is still a challenge in terms of your full API design and its ability to be consumed. So that takes us to what's referred to as API first. And the idea behind API first is now that we do the design work in collaboration with consumer or consumers. Yeah, and then we use some new tools that have evolved with APIs now, that allow us to actually simulate the calls and try making, you know, invoking those APIs and seeing if that's meeting our needs with mocked data. And we can do that and iterate around that and review the APIs together, and develop a good API before any real code is written in anger, either as a consumer or as a provider. Now, the beauty of that is once you've got to a point where you think your API design is good, all the mocking and simulation work is yielding the results you expect, both the consumer and the provider can, in parallel, because there's a nice, clear, strong contract developed, build, package, deploy, test, and then run. As a result, both the provider and the consumer are going to production very rapidly in parallel, which is fantastic, because that means that you've shortened the time frame. Because if you go back to these previous models, your consumer is not really going to get sight of your API until you're up and running and deployed. Which means that you've effectively serialized the consumption and delivery processes. Whereas in the API first, we are now very much running the whole exercise in parallel. And even within a single product development program, having the two teams on the same project, being able to work in parallel, is a huge enabler in terms of agility and speed to delivering a solution. But in any large organization, the chances are the developers are going to come back, and I've heard this had this conversation many times, is, but I don't know who my consumers are. So, but there are a number of ways we can address this challenge. Sort of 5-6 years ago, maybe a little bit further than that, test-driven development was all the rage. It's still valid, it's still talked about, but perhaps not the hottest subject on the market. But it's still good. You're writing your test framework and test consumption of your API before you've implemented the back end. As a result, you are effectively acting as the API consumer. And if you start fudging your tests to get around certain things in your API or likely API design, you're probably going down a bit of an iffy route. And so you're acting effectively as the consumer there. You can evaluate your designs against best practice. This isn't necessarily what I think is best practice, but there's a lot of big players out there have published best practices and patterns and the way they work. And go and look at a company that's been successful with APIs and take their practices. If you're disagreeing with them, then you stop, really think about what you're doing. Are you disagreeing because actually when you evaluate your work, you feel that the implementation is right and the standards are wrong? If that's the case, it should be very rare, and there should be a very good reason to defend it. Use a colleague as a substitute. Just hand the API over and say, okay, what is it? Can you use this? Do you understand it? And that can be with a business analyst who's going to understand the context, but is going to be looking at it from a less technical perspective. They are not going to be weighed down by an engineer's thinking about, how does my threading work behind this? What if I do that transactionally and so on? They're going to be thinking about, does this meet my business goal? You can go beyond your project, and particularly if it's developers, it's better to reach further away so that they're not burdened with the context, because actually your API needs to be able to communicate that context and how it should be used. If you're spending time explaining to these kinds of people what your API is doing, then it hints at perhaps your API is still difficult to use and it needs some working on. Perhaps even share the APIs with public forums just to get some feedback. But it's important that we get our APIs right, because APIs are now the front line of business. This is a little bit old news these days. We've talked about some of the big names like eBay and Expedia, Twilio. The business value is coming through APIs now rather than through their web front ends. But whilst it's easy to say, but that's their business value proposition is through the API. Let's look at smaller examples like Walgreens had a fantastic story where they developed a new in-store photo printing service, and they decoupled it with APIs to make things nice and low coupling and flexible and so on, and decided to dip their toe in the water and make the API publicly available. Suddenly they found they had a leap in the service use because people were picking up the API, writing tools around mobile phones and things like that. So you could take a photo and literally zap it over to Walgreens to be printed. So you walk in and collect it there and then. And they saw a huge jump in their revenue take for the photo printing services. You've got PSD2, which is banking requirements around providing APIs. And that's about trying to drive disruption into the market and competition, and there are new upstarts that are coming into that sector that are just offering APIs or minimizing their presentational footprint because they see the value as the back end and through the API service. But good APIs are absolutely key. There's some research from Cloud Elements where they analyzed and interviewed a lot of large organizations and identified that nearly 50% of all of the people in the survey said good API design is key. And of that, they're recognizing that documentation is also important aspect of it. So APIs are definitely important, and getting it right is essential. So what does a good API look like? Right, so best practice, we would always recommend that you adopt a language that's consistent, that is typically unary. So you talk about a single entity, a car in the URI, not cars, and then using an ID. Although if you disagree with that, and some people do, then be consistent. That's the most critical thing, is be clear and be consistent. The names that you use should be meaningful, semantically correct. Don't talk about cars when actually you mean vehicles. Avoid language that has programmatic meaning, and avoid words that tend to get overloaded in their meaning. API these days is a classic example of that. Some people mean just the API definition, the Swagger file. Others will actually mean it's not just the Swagger file, it's all the supporting material around it and the back-end implementation of it. So let's be clear and make sure people understand what it is we're talking about. Use language in a very consistent manner. US or UK English don't mix color with an OUR and color as OR, as the Americans spell it. And use camel case or snake case, but whichever way you do it, be consistent, because what you'll find is as people use your APIs, if you're consistent, they'll find it really easy because they won't have to look up every API before they use it. They'll start to remember it and use it knowingly, or even if they need to look something up, we'll be able to find the API details a lot more quickly because they'll know, you talk about vehicles, not cars. You talk about planes rather than aircraft and things like that. So agree the use of special characters. My general rule is try not to use them at all. But if you're going to do it with a clear, and again, the theme here is consistency. When you use the $mark, what does that mean? Because that has context. That normally means currency. Using JSON types properly, a classic one is to make everything in your JSON structure string and leave it at that, even when actually you mean a number. So when you put NO being short for a number and then it's a string, does that mean I want the word one, ONE, or do I want the numeric one? Make your life easy. There's a lot of industry standards out there that if you adopt them, you can then just say in your API definition, oh, I'm using ISO 3166 with an alpha 2 character. Okay, everybody can go and look up the correct country code now for the UK, or is GB, or DE for Germany, and so on and so forth. And there are others. Dates is another classic one, particularly when the Americans move the month around compared to Europe. So it's worth using these standards to make it absolutely clear and avoid confusion. Don't put structures into your payload just to make it easy programmatically. Do it because they make sense from a data logical view. It's all about understanding and being able to infer and appreciate the implications of the structure of the data. it will create expectations in your consumer. And then things like passing nulls. Do we really need to pass null? Is it null you pass as a word, or is it just an empty string? Perhaps we ought to be passing these values as optional. If not, let's be clear what we mean. Or even that you can't pass just an empty string and you expect X characters. And then we move on to the more advanced stuff. Let's communicate and be clear about our errors, but don't give away the technical details of the error. So if you get a null pointer exception, don't pass the stack trace back with a null pointer exception, because you're giving people that can attack your API indications about how you've built it and therefore what potential weaknesses to go looking for. It used to be a classic problem with IIS, particularly around IIS 7. If the backend had an error, it passed the entire stack trace back, and you could see how the application had been built and design an attack off the result of that. Maximize the use of your HTTP headers. So it's not just content type. You've got cache control, and you've got lots of other interesting HTTP header attributes that can make your life a lot easier. Translating from not needing to have to define a payload to providing responses without having to build extra stuff. Think about pagination. If you're going to pass lots of results back, how are you going to deal with that? If you're expecting people to use a mobile device, whilst 4G and 5G coming is making data volume less of an issue, we still have weak spots where people have poor signal. Are your users always going to be in a strong network capable environment? So if you're going to pass payloads and pagination, then how are you going to indicate the pagination and which page to provide next? Keep your query parameters simple. Complex parameters are open for a number of problems. One is it makes the code more complex to validate it. And secondly, if you get into I'm just going to pass a filter, which is effectively my where clause in a SQL statement, you're inviting a SQL injection attack. In this example, whilst the top is perhaps a little bit harder to read, it doesn't take too much effort to realize it's saying exactly the same thing as on at the bottom. The difference is at the top, I can be very strict in my validation of the expression. So I can say, right, X must be a value, and then I'm going to pass the X val, and it must be equals or greater than. And then I'm going to pass another value, and so on. And it's very easy to actually pull those apart and validate them without resorting to having to do a fairly sophisticated regular expression process, which is how you'd have to parse it if you used the lower example. And there's actually a number of API journals have started to flag up slow or heavyweight validation as an attack vector, where people are now just swamping servers with too many requests because it knows it takes some time to do a regular expression to validate a complex structure like that. Another way of looking at the quality of your API is to look at it in the light of the Richardson maturity model. Historically, even level 0, the use of a single URI and a verb was quite innovative. We are now, most people are at least level 1, if not level 2. But it's worth just sort of double checking yourself, and some tools will actually do it for you now based on his practices and guidance. Are we in a place for a level 4 maturity? probably worth considering. But you know, should it be beyond just REST now? My opinion, yes, but others disagree with me. And then the last thing that we should be thinking about in our API design is things like the security. You know, GDPR has a statement that says security must be designed into a solution, not added. So let's look at the OWASP top 10, which is the Open Web Application Project top 10 vulnerabilities. And as you can see, every couple of years they publish statistics reporting on what the common top 10 issues are. As you can see, injection, SQL injection, typically broken authentication, and so on are typical issues. And this is about web solutions rather than APIs, but much of this ties back to APIs as well. And we got the analysis here that yeah, we can address a number of these by our API design. Are we sharing too much data? Are we allowing people to inject things into requests that they shouldn't be doing? You know, why not use pre-built security frameworks to do our authentication and authorization? That's not just in, you know, signing into a website, that's signing in to use an API as well. You know, think about rate limiting so that I can't keep asking for data. Think about using HTTPS as well. And you'll note in this one, I've actually, if I jump back, that's the general OWASP top 10, which was published in 2017. And then late last year, they published an API specific one. And if you look carefully, you'll notice that they're essentially all the same issues, perhaps in a different order. You know, so take A8, which is injection, and in the 2017 OWASP general one, injection is the first issue. Yeah, insufficient logging and monitoring as a general issue as A10. Come to API, oh, and look, it's A10 again. So they are common problems. So we ought to really invest both to improve our web applications, but our APIs with it. And part of that's because more and more web applications are powered by the use of APIs. So if I shoot forward, I mentioned the HTTP verbs. We all know about get, post, put, delete, but there are quite a few verbs that are also available that could help us. Sometimes we are not always using the standard HTTP response codes to their full effect. You would post an update to an entity. You could very easily say, okay, right, I've got a conflict here with the version that you're building on, or you know, the data that you've passed is conflicting with an update I've had since you asked for the data and you've updated it. So you can return a 409, for example. That's a lot easier than actually defining a payload that returns an error message saying, oh, you know, the version of the data that you're trying to update is now out of date. You can take a put and say, I can't action this. The server's fine, everything's hunky-dory, but actually I can't action this because you're in breach of perhaps a data validation rule with a 501, and so on. And there's some really powerful HTTP headers that we can use as well that are underutilized, I think. My favorite one is the if match. So you can do a get and say, okay, respond with the body only if it matches with this particular key, or get me the changes since a particular date with the if unmodified since. And then you don't have to explain or return an empty result set. You can just return with an empty body because it's going to be in there, it's clear. it's well defined already. One of the things that's interesting, and it's a bit of a challenging debate in some areas, is the use of API versioning. Roy Fielding's argued in his original paper that you shouldn't need to do it. But the one truth, the one constant in life, as the saying goes, is change. And how do we deal with the fact that we do need to change our APIs and improve, and people will want more and new features? So there are a number of different strategies to solve it. There's a set of common patterns, but the important thing is handling versioning is the key, or handling the way we deal with change is key. If you keep breaking your API, you're going to lose users if they've got a choice of switching away. If you don't version it, then how do people know that it's going to work? And these are the sort of considerations you need to address, because sooner or later an API will need to change. Yeah. And how many versions are you going to support of your API? Is it the last one, the current one and the last one, or go back further than that? So one way of doing it is to apply semantic versioning and put it into the URI. We've seen this. This is probably the most pervasive one. And you can see this, but think about, what does it mean? Am I versioning my whole domain in the first example? Is my versioning in the second example actually v1 the entity using the RESTful naming convention that everybody advises you of, entity name, entity identity? So have I got an entity called v1, or am I saying version 1 of what comes next? Or am I saying version 1 of entity? And the same goes when you put it there. So just need to be understanding of how that can be easily misread. Most people appreciate the first approach. You can put it into a header attribute. This is one of my more preferential routes, because it's easier to actually codify. But there isn't a standard header convention for doing APIs. You can use the accepts model. This is really painful in many respects, because it puts the onus on the requester to say, I'm only going to work with your version 2 of your API. It's quite long-winded to achieve. It requires details to go into the request header explicitly. And not many people use it, but this would be the model if Roy had his way that we probably follow. And then my favorite, which is called non-breaking evolution. And what this does is basically takes a principle that's actually embodied into some of the newer API technologies like GraphQL, amongst others, and says, okay, you can change your API, but you do it in a particular way. And then when you get to a point where actually you need to break it because your API is talking about cars, but you've expanded your business to look at lorries and cars, then actually you leave your cars API in existence and you build a new one and change the entity to vehicles. So you've never broken cars. What you might do then say is, okay, this API has got a limited lifetime because everything should be talking about /vehicle, and move from there. HateOS is a bit of a hot topic, using links within a payload to describe how to get other attributes. Some people love it, others people hate it, but it can be useful. It does help the consumer, even if they don't use it, and they construct their URIs rather than saying, okay, I'm going to get the href for a HateOS link and call the service that way. But you are showing them how to use other facilities that you are providing, or even how to take your value, your data, and pass it into another third-party service. Like the last example here, add to cart is actually going to a shipping cost is going to a different domain and taking the values that I've provided and pre-populating the URI for you. So, you know, if I've got an object and I've passing details about the weight for you, then actually I could put it into the URI for the shipping cost calculator provided by my preferred shipping provider. And that really can help people as well. But APIs are more than good payload descriptions. So we spend a lot of time focusing on the Swagger or API blueprint definitions, but it's beyond that. You go look at the good APIs, you know, Google or Amazon, and people like that, and what you'll see is there's a lot of extra contextual information, illustrations. They'll explain some of the language. They'll explain how the URIs are built. They'll talk about how their versioning works. They'll talk about any rules of using the API and what will happen if you abuse it. So what's the limit of the number of calls that I can make? That's quite important if you're using a geolocation service or an address location service. For a big enterprise solution, you might be making hundreds of thousands of calls. And if it rejects one or you get an error, why is that? Is that because I've asked for too many times, or is it something else? So talk about your rate limiting, talk about your authentication and authorization mechanisms. Is it a token? Is it authorization? Is it completely open? And also you've got to think about your T's and C's. What you don't want to do is offer an API and then get caught out because someone's misused it and left through that misuse left you liable. If you provided an API for a service that goes and federates somebody's blog content, if that blog content is damaging or illegal in any nature, all of a sudden your API service might be in breach of and legally liable for your users' actions. So worth considering and making sure that you've protected yourself from from legal liability on public APIs. Think about rate limiting, not only for protecting your back end, but to ensure that other clients get fair access. You know, even if things are elastically scaling, there is a little bit of lag between the startup and an API request being served. So that's worth considering. And if your system is more of a legacy one, your scaling might not be that elastic. So you might want to then constrain how much workload is being put in by any one customer or user of your service. And then, you know, what are your commitments to your consumers? Will you compensate them if your service goes down? You know, if you're clear and upfront about it, then people will go in knowing full well what they're getting, and you've got no comeback, or they have no comeback on you. At least you have, even if you have an outage you never expected on your service, you can then say, well, you know, we do everything we possibly can, but, you know, in the T's and C's, it does say, sorry, it's down to you. So if they put a mission critical dependency on you, then it's their call. Documentation is absolutely critical for getting your description and use right. If it's not well documented, people are not necessarily going to understand it, or they'll use it in the wrong way. You know, providing code samples is a great way of helping with that. But there you go. So, SDKs are another way of helping to make the use of an API easier. This is quite common when people expect mobile apps to be using APIs. They'll quite often just provide a framework that's can be compiled into their app rather than making them have to work out how to build a JSON payload or provide the YAML configuration and things like that. And there are a bunch of tools to test and make sure that your APIs are usable and simple and easy. API-matic, API tools, REST United, Swagger CodeGen can be used to build the frameworks for you. Auto-REST will generate code for you. So you can bundle that very easily in multiple languages to make people's lives easier if they prefer just integrating with a little bit of Java. Well, I'm trying to work out how to use Jackson or another library in Java. Then you've just simplified reduced the resistance, made the adoption a lot easier. I mentioned APIs from code. I'm not a personal big fan of it because ideally the API should be decoupled from the business logic and how the data is persisted. But if you do a code-led approach, you run the risk of collapsing the layers, and as a result, you changing the persistence layer changes your API, which impacts your consumer. And that's the last thing in the world you want. Because you're going to discourage people from using it. It's a cost implication for private APIs to consuming teams and so on. So a good illustration, just to sort of drive home my point, I went to Google Maps and said, okay, I'm going to grab some screenshots of the Google Maps API material and see how many of my principles hold true. So here's the Google Maps homepage, and there they are talking about providing SDKs for mobile platforms and the API. In here, they're explaining and making sure that you understand the kind of audience they're trying to communicate with. So if you're a business analyst, then seeing this, at least you know it's reasonable not to necessarily understand everything, and you might need a dev to help you evaluate whether this will meet your needs. They're giving you example content. And moving on, they're talking about the rules about authentication, rate limiting, prices, the rules about using the service and what they'll do. And if we look at this example that they've given you, they've explained the fields, and you'll see in here that they've gone for a lot of attribute parameters in there, and they're well defined and well bound in terms of what those values are for. If we keep looking, here's an explanation of exactly what the value means, how to read it, how to use it. And they've talked about the legals. So, and that brings me to a conclusion of, hopefully you've seen a number of points here to drive good quality APIs.